Yeah, I created this Minikube, Terraform apply auto approve, just our Minikube code. So that was already here. And then, so let us copy this. So here when we apply this, we will get kube config. Okay, so this is where Kubernetes authentication file exists. Okay, we need to just copy that. This one. This is DevOps Class. Okay, so we need to install kubectl. I just forgot to keep it inside the automation script. Kubectl install CentOS 8. Commands. You can place them in our Docker installation script. Okay. So now just create one directory .cube cd.cube, and here the file name should be config, because kubectl automatically get this. Now kubectl get nodes. Yes, our cluster is ready. So we started discussing resources, Kubernetes resources. So that is namespace first. Okay. So namespace is like a project, like VPC. It has some space for projects. Within the namespace, we can provision our resources. So when we are discussing with AWS services, so we have few services that are attached to the VPC. For example, subnet, it is attached to the VPC. Security group, it is attached to the VPC, and load balancer. So everything is attached to the VPC resource. So there are VPC level resources and non-VPC level resources. Like Route 53. This is not attached to the any VPC. So this is non-VPC level resource. Okay. So similarly in Kubernetes also, there are namespace level or not namespace level. Namespace level is true or false. Okay. Few resources we will attach to the namespace. Few resources we don't attach to the namespace. Okay, so that is project level or cluster level resources generally. If you just see this here, kubectl get resources. This is the command. Kubectl get resources. API resources. Kubectl API resources. Now, if you can see this here, namespace true or false. So bindings is a resource attached to the namespace, and then component status is not attached to the namespace. Config maps attached to the namespace, and then something else. What is this? Nodes. not attached to the namespace. So there are two categories. One is your resource is attached to the namespace, or your resource is not attached to the namespace. Okay. The namespace is just like a VPC. Project resources are provisioned inside the namespace. If you don't give any namespace, a default namespace can be used. So the next resource is pods. Okay. So pods are smallest deployment units in Kubernetes. Okay, same as containers, but there is some difference between pod versus container. Okay, so here what is pod versus container is, one pod can have multiple containers. And all containers inside pod share same storage and network. Okay, so this is the difference between pod versus container. Generally in Docker environment, we call as container, but inside Kubernetes, we don't call as container, we call as pod. Okay, so now just let us see simple definition of pod, then we can understand better. Let us take the Kubernetes definition. So this is the syntax. As I said, every resource in Kubernetes, API version, what kind of resource you are provisioning, and metadata. So these are common, but for the container or generally we need to, what we are giving Docker run -d-p, and then Nginx, something like this we are giving, right? So this configuration comes under spec. Okay. So something like this we are giving, right? And then -- network and volume. So everything we are giving inside the Docker configuration generally while running the image as container. The same kind of configuration you have to give it inside the Kubernetes. So now what are we doing with Kubernetes is we are not using Docker to run images. Okay, we are going to use Kubernetes to run images. Okay. So runtime environment, we are not using Docker, we are using Kubernetes. So you need to write Kubernetes manifest files to run the pods. Okay. So this definition is like this. So let us create pods. Pod.aml. API version is v1. Kind is pod. Metadata, can create metadata inside that name of the pod. What is the name of your pod? For example, simple pod, I'm writing it. Just naming it as simple pod. And here, if you want to attach to the namespace, you can attach like this namespace RoboShop, for example. If you don't give this, then it will attach to the default. If you don't mention specific namespace, it will attach to default namespace. Okay. So here they didn't mention that namespace will be there generally. Yeah, it's okay. So they mentioned the default pod and then spec. Okay. So inside spec, you will have containers. As I said, it can have multiple containers. So you are getting a list. You can say this. So now containers. what is the name of the container you are going to write? Nginx or Nginx simple. And you need to mention the image. So what is the image? Is this one. And container port. So what are the ports your container is opening? Right now we are still not mapped with our host. Okay, so that will come later. So this is the simple pod definition. Maybe in interviews they will ask you to write a simple pod definition, but this should be the bare minimum. You should write it. Okay, so with a lot of practice, you should understand API version, kind, metadata, and then spec containers. Inside containers, you can have a list of containers like this. Okay. So now let us push. And pull these things. Okay, so I attached this pod to the RoboShop namespace. So I should first run this namespace actually. kubectl apply -f namespace. Okay, namespace got created. Now I should go to the pods kubectl apply -f 01 pod.yaml. Okay, pod created. kubectl get pods. So it is saying no resources found in default namespace, but I didn't provision the pod in default namespace. I provisioned in RoboShop namespace -n namespace and then RoboShop. So now kubectl will get the pods from RoboShop namespace. Now you can see it is running. Okay. So how can you log in inside the pod? So that is nothing but kubectl exec-it, your pod name, and --bash. And as I said, it is again -n RoboShop. Okay, now you are inside the pod. Just run curl localhost, curl command also not found. Need to install curl. At etc Debian. Curl install Debian. That's not, this image don't have this curl and I'm not able to install. It's okay. Let us say this netstat exist. Oh no. ps-ef grep nginx. ps command also not found. Okay, it's fine. So pod is running actually. kubectl get pods. Okay, pod is running. Now, how can you delete this? Again, kubectl delete -f. Your pod will be deleted. Okay. So as I said, pod can have multiple containers and they share the same storage and network space. So this is important. Why we should have multiple containers? Why Kubernetes gave us that option is, so let us understand that. Multi-container. So if you remember our ELK, so what we were doing is in ELK, for example, so this is our VM and we have our ELK server, right? Elasticsearch. So what we were doing is we installed some agent here, like that is like FileBit. Okay, so we installed agent. So this agent was referring to something var log, some file messages or nginx log. Okay, it was this agent is referring to this messages and then it is pushing those messages to the ELK cluster. So this is what we were doing in our VM environment. Similarly, inside pod, so we will run multiple containers. Okay, so one is nginx, for example, and we will run FileBit. Okay, so this nginx is storing logs inside var log nginx access.log or error.log, right? So it is storing messages here. So what our FileBit will do, as I said, it will share the same storage and network space. So this FileBit can access this log and it can push to the ELK cluster. Okay, so this is pod. So you may get this question, pod can have multiple containers or not? Why pod is having multiple containers? So you can say yes, pod can have multiple containers. That's the difference between container and pod. So all containers in the pod share the same network and then storage. The scenarios where we use the pod is sidecar containers. So these are called as sidecar. So sidecar, if you see some extra fitting. So this is the sidecar for the bike, right? Similarly, this is the sidecar for the this container. This is the main container. This is sidecar container. This is doing some help to this main container. It is accessing the log files and then pushing them to the ELK. So this is called as sidecar. And then there are other patterns that is proxy. So multi-containers can be used in sidecar patterns and then proxy patterns and init containers generally. Okay. So these are the advantages. We may get it in for upcoming sessions. Okay. Just we need to understand a pod can have multiple resources. Sorry, multiple containers. Multi-container.ml. So the same definition. API version v1 and then kind pod and metadata name multi container, for example. Not giving namespace, this will go and attach to the default namespace. Spec, inside spec we have containers, list of container, name I'm going to give Nginx, image as Nginx. Okay, let them take latest. Okay, and then another container. You can see this carefully. I'm giving another container under the list. Now you can say some sidecar image and say our Alma Linux 8. Okay, so this should be the bare minimum configuration. This one ports, this is not a mandatory thing because it will automatically open port number 80. So this is for just the information. Okay. So now I'm creating a multi-container pod. Inside that I have created 2 containers. So now let us push and then pull. kubectl apply -f 02 multi-container. kubectl get pods. Now you can see 0/2 already. 2/2 running. Now 1/2 running. Another one is not ready. You can see this. So it is automatically trying to restart. So why another one is not ready? It is because this Alma Linux. So generally Nginx by default, it will run automatically for infinite time, but Alma Linux generally it will not run automatically. So it will be so it will be exited because you didn't have any command to run this Alma Linux container for infinite time. So that's why we used to give something like this command. I'm giving sleep 200 seconds. So then this container will be alive for 200 seconds and it will get exited. Okay. Now if I pull, so let me apply. Okay, few things you cannot update. You have to delete and then recreate. Something is wrong here. Okay, so this one we should give in this format. Hit pull. Now you apply kubectl get pods. So now 2 are running, 2/2 are ready. You can see the status is running. So after 200 seconds, again, you will get an error. But within that, let us kubectl exec-it multi-container. So we have 2 containers inside that. Which container I want to log in? You have to mention -c container. And I want to log into this sidecar and -- bash. Okay, now let us see curl localhost can see welcome page. So I logged in inside the second container. Okay. I didn't install any Nginx here, but it is still able to access Nginx. That's what I said. They share the same network, right? So Nginx is installed here inside Nginx container, but FileBit is able to access Nginx because they share the same network. Okay, FileBit can access this one, and you can see this Nginx logs also it can able to access. For example, let us go var log Nginx. That is the directory. etc. It should access. Okay, let us log into the Nginx container. So here we have access log and error log. So this should be accessed by sidecar as well. Okay, yeah, actually we need to do some setting, that is volume mapping. So that one, so we'll discuss this sidecar pattern. Okay, so we'll push our RoboShop logs to ELK cluster. So at that time, so we need to do some volume mapping. Okay, so that one we will discuss at that time. Okay, for now you can see it can able to access the same kind of network. So even you are inside the Alma Linux, you are still able to access Nginx website. To access the storage, a small setting is required. We will do that later. But remember these points. Okay, same network and same storage. Why we need multiple containers inside a pod? Because for these advantages. Okay, so and next thing we will discuss is something called labels. So you know labels already. So we discussed that as part of our let me take the Nginx, this one. Name is going to be labels, not using RoboShop namespace. So we discussed labels in containers. Now in Kubernetes labels, so here labels is just like inside metadata, you will mention labels and then key value pairs, for example. So let me take this labels and here key value pairs, environment app, something like this. Environment production and app Nginx. So in Kubernetes labels have some advantage. Okay, so that is so labels are used in selectors. Okay, it has some functional advantage apart from filtering. Okay, so we'll see this while we'll discuss about the services. Okay, so it is not just for information, it will be used in the functionality as well that we will discuss for now. So this is the syntax. Inside metadata, you will mention labels, and then you can have key value pairs, any number of key value pairs. Okay, git pull, apply, kubectl, apply -f03 labels. Labels created, kubectl get pods. So as I said, this is in error because 200 seconds is over. Let us delete that. Kubectl delete -f02. Okay. Now kubectl describe, you can describe the pod just like Docker inspect and then labels. Now you can see all the information about the pod. You have your labels, app equal to Nginx, environment equal to production. And similarly, you have annotations also. So labels versus annotation. Okay. So labels can't have special characters in key names. Okay. Annotations can have. So label key have some length restrictions. But annotations can be length can be more labels. Okay. And then labels are used in Kubernetes resources selectors, but annotations are used in selecting external resources. Okay. So you'll understand these later. Labels and annotations have the same purpose, but labels are used to select internal K8 resources. Annotations are used to select external resources. If you just type labels versus annotations, so this one, we will see that maybe at the end of the course, because that concept will come at the end of the course. You can see that the metadata in an annotation can be small or large, structured or unstructured. It can include characters not permitted by labels. So that is the main difference actually. So, and you can see here just a key value pair, but inside annotations, you can see special characters like slash, dot, and the length is very high. Okay, so these are the annotations. Zero 4 annotations. Same as labels, but here it is not this one, annotations. You can just mention like com dot project dot author, something like this. Space generally. and something, anything, chrome.project.name RoboShop. So these are annotations. Okay. Careful kubectl apply -f04 annotations. Kubectl get pods. Describe it. Kubectl describe pod and annotations. Now you can see our annotations should be added here. com.project.author, com.project.name, something like this. Okay, so this is about labels and automations. And the next resource we can see is resources itself. So what is the main advantage of VM and Docker is, I said, resource utilization. Okay, so VM, while creating any VM in your laptop, you need to mention something like 1 GB RAM and 5 GB hard disk. Okay, so even you are not using 1 GB RAM and 5 GB hard disk, it is completely blocked in VM. But the advantage of in Docker is you don't need to specify any resources. It can dynamically take the resource, dynamically consume resources. It is not blocking system resources. But here there is one disadvantage. By mistake, if something is going wrong inside the code and it can consume more memory, generally we will have application logs. Application logs can consume more memory because of some code defect. So, okay, in this case, as we said, we can images, Docker containers or any containers can consume the resources dynamically. So there is a chance container can block complete system resources. Okay, so this is the advantage and this is a disadvantage. We have both advantage and disadvantage if you let Docker containers or any container to consume the system resources dynamically. So just to come out of this disadvantage, what we have is we can implement resources. Okay, resources limits. Now let us see this Kubernetes resource limits, resource management. So here you have to mention what is the request, what is the limits. Request is a soft limit. So resources are not blocking. Resources are not blocking the memory and RAM. Kubernetes is just monitoring pods should not consume more resources than mentioned. Okay, so this is an important topic usually for the interviews also. How can you stop containers not to use more memory and RAM? Okay, more memory. This is CPU and RAM. Okay, so requests, this is soft limit. So this is hard limit. The soft limit is nothing but, okay, so resources are 64 MB and 250 M. 250 M is nothing but, so one CPU equal to 1000 M, 1000 millicores. Okay, 250 M equal to 0.25 CPU. Okay, so we are giving these resources, but it can go up to 128 MB and then half core. Okay, but it cannot cross more than this. Okay, so this is soft limit, this is hard limit. Soft limit, we are okay, it can go up to 100, 110 also, but hard limit, it cannot go more than 128. Okay, so now let us mention that resources dot YAML. Okay, sorry, API version v1 kind is pod metadata name resources and then spec image, anything generally, Nginx also. For spec, inside spec we have containers, list of containers, name is going to be Nginx, and then image also going to be Nginx. But here you must mention the resources. Resources, inside resources we have requests, and inside requests we have something like this, memory and CPU. Okay, requests don't have hyphen. So requests, and here CPU is like 100 M is enough for us. And then memory 128 MI, it's nothing but 128 MB, and then limits CPU is 200 and then memory is 256 MB. Okay, so that's it. So inside spec containers, if you have multiple containers, you can mention it to the every container. So this is the soft limit. So this is the hard limit. Now, whatever your app is like, it is by mistake because of application code defect, it may be getting into the locks, and then it may consume more memory, but it cannot exceed than this, so that other containers will not be affected inside your Kubernetes, other containers and pods. If you don't mention this, it can block the entire resources of the server, so that other pods and containers are affected. Okay. Git pull kubectl apply -f05 kubectl get pods. Okay. Now kubectl describe pod resources. Now your resources are mentioned somewhere. You can say this here. Okay, so that's how you mention the resources. So next thing I will discuss is image pull policy. Image pull policy Kubernetes. So what is this image pull policy here? Let me open. The day before, so last week, we just drawn something. Okay, so what I mean here is image pull policy is a simple concept. So we are pushing images to Docker Hub. Okay, so where this Kubernetes is pulling these images, whatever we mentioned here is, it is from Docker Hub, this image, Nginx image. Like we push RoboShop images to Docker Hub and we are running Kubernetes pod. So it is running, Kubernetes pod is running, your application is running. Now developer did some change. Developer did some change and he pushed new image to Docker. Okay, since he pushed new image to Docker, generally we run Kubernetes pod again, like kubectl apply -f pod.ml. Okay, so but there is some option here, image pull policy. Okay, image pull policy Kubernetes if not present, it means, so here Kubernetes already pulled images here, already pulled image default. This is default behavior. Okay, so but what I'm saying here is developer pushed a new image to the Docker Hub. We need to pull again. So for that purpose, what we are saying here is always. If you mention image pull policy is always, so Kubernetes, every time it will pull the image from Docker Hub so that it can get the updates immediately. If you don't mention then this one, so then your Kubernetes will run again the old version of your image. Okay, so that is the pull policy. Actually, it is a simple option. We just keep it inside the image, this one. This image pull policy. So you just mention as image pull policy always. That's it. So nothing much here, just wanted to mention this one. So now Kubernetes will every time pull the image from Docker Hub so that you will get the updates. If you don't mention this, it will run the previous pulled image. Okay. Just running this. Yes, and now image pull policy is always. So you cannot see this, but you may see this in our upcoming RoboShop sessions. But it is always good to have you pull image pull policy is always. This is also an important interview question. What is image pull policy? You can say we are using always because so there may be updates to the images and then push to the Docker Hub. So at that time, we will pull the we will pull image every time so that we'll get the latest version of the image. Okay. That's it. And then next we can say Kubernetes environment. Okay, again a simple thing. You will mention environment and key value pairs so that you can access these things in your container. Okay, just like in Docker, we will mention this one 06 environment.yaml. Okay, just taking this. Just giving engines. Okay, inside env section, so there will be names and values. kubectl apply -f06. Okay, it is created. kubectl exec-it envar demo bash. Now just type environment env. So you will have what is this environment demo greeting. You can see demo greeting, something like this. So you can access the environment values within the container. So generally useful to mention the database URL and any other configuration your application requires. Okay. And another thing is config map. So one of the best practice is keep the configuration away from container. So this is one of the best practice we discussed last week. How can you keep a configuration away from the container is, so there is something called config map, Kubernetes config map. So this is a resource, kind is config map, meta. Inside that data, you will have just key value pairs. So this is key and this is value. This is key and then this is value. And then, so this is key and this is the value. So value can be multiple lines also like this. Okay. So now we will create one config map and then we will attach that to the pod. Okay, so let me create one config map. So API version v1. It's v1 only, right? Let us just check. Yeah, v1. Oh, spot. Yeah, it is. Sorry. Yeah, v1. And kind is config map. CCAP, sorry. Kind is config map. Metadata. I'm just giving as name as something like course config. And then syntax here is data. So inside data, you can mention your key value pairs. Now I'm giving course is DevOps duration is 100 hours trainer. So this is my configuration, right? This is my configuration. I need to attach to the pod. So let me first create this. Git pull kubectl apply -f07 config map. So config map is created. You can just access this kubectl get config maps. Now you can see course config is created. Okay, if you just want to see kubectl describe config map and course config. Okay, now you can see this data duration is 100 hours. Trainer is Sivakumar. Course is DevOps. So we have the configuration created somewhere. How can you attach it to the pod? Okay, I'm just going to create config and then pod.ml. You can just see the syntax also here. So inside the same kind of env, and then for example this one is course. Now value is not going to be hard coded. It should fetch from the config map. So for that purpose, you can just give value from, okay, from where we are getting the value, config map key reference. Okay, and what is the name of the config map? So this is course config, and then what is the key you are getting it? The key again there it is course. So now, so inside my pod environment there is a course, but the value I'm fetching it from the config map. So that is why I mentioned as config map key reference. The config map I'm referring to is course config, and inside that course key. Okay, so similarly you can just mention there is no guarantee this and this one is same. For example, here I'm just giving it as person and value from same config map, but the key here is trainer. Okay, and then duration. Okay, name is like config pod. Okay. So now what is the advantage? In future, the values are changed. You have to just change in this config map and restart the pod. That's it. Okay. So now kubectl apply -f08. Git pull kubectl apply -f08. Okay, config pod created. Now let us just exec -it config pod bash. Now you can see env. So whatever the keys you have given, course and then person and duration. So everything is getting from the config map. So now the advantage is here what? For example, I change the values. So instead of 100 hours, it is 120 hours. And then I'm pushing it. Cube git pull, kubectl apply -f07. Okay, so this is configured. Now instead of changing your pod definition, I can just restart. Restart is nothing but kubectl delete -f08 and apply. Now exec and then see the latest value is referred obviously 120 hours. So I'm not disturbing my manifest. That is the advantage. Okay. So let us take 5 minutes break and then we will continue. So we'll see at 8:23 again. So this is how we will attach the config to the pod. But imagine if three variables we are attaching, this is good. But what if we have to attach 50 or 100 variables? This will become very, very lengthy. So instead of that, so what our Kubernetes is giving us an option, you can directly refer the full config map. Okay, for example, let me create another one. Config pod direct something. Okay, so instead of like this, you can say Kubernetes env from config map. Configure all key value pairs in config map as container environment variables. So that is this one. You will have env from config map reference, then everything in your config map will be referred as environment variables inside your pod instead of mentioning one by one. So now instead of env, just that is env from. Okay. So there is this one config map reference. You can just mention it as force config. That's it. Just mention like this. Okay. So now you don't need to select one by one. Everything inside config map, you will get the full access as environment variables. kubectl apply -f 09. Okay. And this is the pod. You can check kubectl exec-it bash env. So you got everything. Okay. So this is the config map. So it is very important. Generally, we use this config map in our projects. to mention your application configuration. Okay. Similar to this config, we have something called secrets. So database URL is not a secret. Okay. But database username and password, that is something confidential information. You can keep URL in config map, but username and password you cannot keep it because everybody can read. So you can keep it inside secret. Okay. Simple secret can be. So, but here you can see the secret data, you should not store it as plain information. You should store it as base64 encoded. Okay. So let me just create something here. 10 secret.aml. So API version v1 kind is secret metadata and like just keep it the same name. Type is not required. Should not be string data. String data is nothing but you can mention the username and password in plain text, but keeping it in plain text is not recommended. So that is why we are giving data here, and you should give username and password in base64 encoded. Username, for example, let me take it base64 echo. For example, username is Sivakumar. Base64. So this is the encoded form of this one. Okay. How can you decode? Generally, decode. But here you need to give the value. Okay. So Sivakumar encoded value is this one. You just need to mention this one here. For example, and password. Password, if I need to mention ABC123. ABC123. So this is the encoded. So this is the secret. Now I want to refer this inside the pod. So just mention 3 dots like this. You can mention another Kubernetes resource again here. Okay. Secret from pod. I'm just taking this. And then. So you can mention one by one actually like env. So as we mentioned here, env value from, but instead of config map key reference here, you can just say secret key reference. That is fine. But I want to get all the secrets at a time. So now you can just refer secret, all secrets in pod env. If you just search like this, you will get env from Kubernetes env from secret. You can mention like this, but I want everything. So is there any no option or not? So you can mention like this. So this one, you know how to refer one value. So this one, we know this already. So instead of value, value from secret key reference, name of the secret, and then key. But instead of that, I want to mention everything at a time. So I will just mention like this. Okay, env from secret reference. What is my secret? This is the secret. Secret pot. Git pull. Sorry, not here. Git pull kubectl exec -it kubectl apply -f10 kubectl exec -it secret pod. Okay, now you can check env. You can see it is automatically decoded. Okay, confidential information we store in secrets. General information we store it in config map. So these are the main things we use in our daily work environment with Kubernetes. Okay, pod, just simple thing, pod definition, IP version, kind, metadata, spec, and then resources we will mention, labels we mention, environment we will mention, we will use config map. So this is how you can work with pods. Okay. So now pods are running. How can we let the users access these applications? As we don't have any port mappings here to open it from the outside environment. You can see this. We are just seeing it is running. How can you give access for the users to access the pods? Okay, so the next topic here is very important topic. That is nothing but services. Okay, Kubernetes services. Kubernetes service. So service is a method of exposing your application to the outside world. So there are three types of services here. One is cluster IP, and the other one is node port, and the other one is load balancer. Okay, so load balancer is only for cloud related Kubernetes. So we'll see cluster IP today. For the next two things, actually, we need Minikube is not enough. So we are going to provision the actual cluster from tomorrow's session. Okay. And yeah, so we will consume those things. So now let me create something called services. First thing, cluster IP. So this is the, so let me create first pod. Okay. And let us delete all pods, kubectl get pods, kubectl delete pod. Okay, all pods are deleted. So I'm just creating one pod, Nginx pod, and labels. I'm just mentioning it as environment dev, and then app is like front end. Okay. So I'm mentioning a pod definition like this. So let me create the pod first. Git pull kubectl apply -f kubectl get pods. Okay, pod is running. I want to attach it to the service. Service is nothing but there are multiple advantages. One is to expose your application to outside world, and then to balance the load. Okay, so this we will see the time of deployment and replica set. Okay, so you cannot see this right now. How can it balance the load? First, we will expose it to the outside world. So that is what it is. Two advantages. Okay, now how can you attach this pod to the service? So you have to write service definition, just 3 hyphen, and then this is the one. API version kind is service, like Nginx service. I'm just giving selector. So this is where I said selectors. Labels are useful while selecting your application. Now, what are the labels here? Environment dev. I need to mention this one. And then app front end. So then service, when it is provisioning, what it will do is it will go and search for these labels in the pod. And if we find this pod, then this will go and attach to that. Okay, so very simple. And then port also. So here, so we will have service, we will have pod. Okay, so this service is going to be attached to the pod, and this service will have one port. Okay, this is service port, and this is container port. This is service port, and this is container port. So it is important to provide the port number also, otherwise service cannot attach. So this port is belongs to service. This port belongs to service. But this port belongs to container. Okay, just I mentioned a name here. You can directly mention the name here. That's it. Whatever the name you mentioned, you should mention it here. Okay, so now git push, git pull. Now you apply again. So pod is already created. That is why it is saying unchanged. Now service is created. kubectl get service. Okay. Now you can see you got an IP address for your Nginx service, and then it is attached to port number 80. Yes, by default it is cluster IP. So it is internal to the cluster. Internal to cluster. And you cannot not exposed to outside world. Only exposed to cluster. Only exposed to inside cluster. Okay. So how can I check this? Now let me provision one pod. kubectl apply -f01. So apply -f pods 02. Okay, kubectl get pods exec -it multi-container -c sidecar bash. Okay, now I am inside another container. Now if you access this cluster IP card, now you are getting the Nginx page. So now, as I said, it is exposed internal. It is exposed inside the cluster so that you can access your cluster IP service from another one. Now you can just access with the name also. IP address keeps on changing. For us, the important thing is name. Now Nginx service. Now you can see just with the name, you are able to get the page. This is very useful. Like, when we are practicing with the Docker, we just gave name to the container. The IP address keeps on changing, but the name will never change, so that you will get the response. So similarly here, this will be used as service mesh also. Okay, what is service mesh is nothing but your IP address keeps on changing. So instead of accessing with IP address, you access with name. So that is called service mesh. Cluster IP can be used like that, but it is only internal to the cluster. So that is why I logged into another container. I accessed with this one service name. So I'm able to access. Okay. So node port and load balancer, generally these are used to expose the application to outside world. So this way we'll see it from tomorrow's session. So that's all with Minikube. And then further services, we need the actual cluster. Tomorrow we will create the actual cluster, and then we will practice the other services. Okay, that's all for today. Let us have few questions. Arvind, you have some question?
Yeah, Shiva, parts, I can consider parts as an images, or in the parts we will be having images.
No, what is container? Container is running version of image, right?
Correct, yeah.
So pod also same, but it can have multiple containers, that's it.
Okay, fine. I got it, Shiva.
Yeah. So any other questions from anyone? So practice till here using Minikube. Upcoming sessions, we may require the actual cluster. Suresh Yen.
Hi Shiva. Shiva, actually, what is the reference of parameter name inside the metadata?
Name is name of your resource, what you are going to create. So I just need to give some name, right?
So can we give any name, because we are giving the name under the containers as well, right? Here that name and under the metadata name, both names are equal, should be.
No, it's not. It's not should be. So this is the name of the pod. So this is name of the container. You can give anything. Sometimes I'm giving name same because there is only one container here, right?
Yeah.
So if you have multiple containers, you cannot give the same name to another container.
Okay. Okay. Shiva, can we use that name under the metadata anywhere? That particular name?
You can use any name. Okay. And here also you can use any name. It can be same or different. That is not a problem. That's not a problem.
Okay, Shiva. Thank you.
So Rajashekar Reddy, another question.
Hi Shiva.
Hi.
For example, I have 6 microservices. Currently, I'm doing 6 microservices, 6 pods.
Okay.
So you introduced today multi-container, right? So if I use only one pod with multi-containers, 6 services,
Yes.
how can I down with one service and how can I deploy immediately without stopping other services?
So that is not how we are going to do. Okay. So we will have generally with services,
Mm.
and then even pod also we are not going to use directly. We have something called deployment. Okay. We will use those resources. You'll get full clarity in 1 or 2 sessions.
Okay, thank you.
Okay. So just practice till here, understand what is pod, and then get some hands-on on how to write the Kubernetes manifest syntax like this. And from tomorrow we will discuss about services, node port and load balancer. Okay. So that's all for today. Have a nice day. See you in tomorrow's session. Bye-bye.